How's it going, everyone? Welcome to another video. Elder Gonzalez here, talking about front-end system design, which is a course taught by Yvonne Ray, software engineer that has previously worked over 3 years at JetBrains, and then now he's currently working at Meta. And he, in this particular course, described that if you're going to be a UI specialist, you need to learn the fundamentals of how you're going to build this front-end systems at a scale, right? So this is something that this is the service that you are going to provide as a UI specialist, right? This is the value propositions that you're going to offer to any business. So because of that, and at the end of the day, all of these top tech companies are pushing the boundaries, similar like us are doing that. And this might sound quite hard to hear, but shoulders are meant for load. Shoulders are for loads, hips for loving stuff. So hips are not meant for carrying loads. And by that I mean is that if you are truly going to dedicate time and you want to provide this service in a professional way, we need to learn these fundamentals. So, because at the end of the day, companies are going to expect you to provide and solve their problems. You're gonna get not only money for that, but then with that money you can now explore other areas that you see fit, that resonate with you, that also can contribute to that field. So we don't want to go into the philosophical aspect here. Okay, I really love to always go and take that particular route path. But in today's video, I'm going to now is describe what we're going to do, and that is looking at the Observer API in on the web, because now this solves specific problems that are recurrent as a UI specialist, as someone that now design and develop these front-end applications. Okay, so the observer is also a design pattern where now we want this is a behavioral design pattern. So the observer is pretty much like when you want to get notifications from a celebrity, all right? You want to subscribe to their events. Not only celebrities, but also people that you admire on social media. You admire, that you want to follow, perhaps writers, musicians, artists, athletes, or even college, family members, that kind of thing. So because that is a pattern, and I mean by pattern in this context of the design pattern is, well, this is a typical problem, this is a typical problem, or this is a common solution to a typical problem, right? And the problem is that how can we now get feedbacks or their news from people that we care about, not only on our profession, okay, but perhaps coaches or any that we need or what we find valuable at that moment, right? Perhaps it can be, as I mentioned, artists, writers, athletes, even business people, entrepreneurs, politicians, rulers, your own mom. You're right. So all of this. So how can we now, well, find a way to always get there? So the idea here is that by having this particular pattern or this particular solution, which is we're going to subscribe to that as they call subject, okay, for events, and in this case is to cover is specific use cases. So for example, when we need to show elements as we scroll, or when we need to know how many visitors for marketing purpose. Let's say you want to actually check is on your web app how many users actually are visiting your website for analytics, and also for loading components, lazy loading components. So there is a particular problem that happens, okay, and we come up with a common solution with the interception observer. The other is the mutation observer. It's like, well, how can we now, anytime that the DOM change, we need to find a way to keep track of all of those changes, right? So this is useful for typing, so any text-rich editor. Or for example, this is widely used on that. For example, Notion actually use that. For text-rich editors, and for text-rich editors, okay, in drawing tools, okay, for example, if you're working with SVG elements, drawing tools is how you can now actually is track all of those elements down there, right? So drawing tools. And the other is this is using the mutation observer, something that we're gonna discuss about in this today's video. And then is the resize observer, right? Where how can we now show, for example, data given the particular viewport, and how can we make them responsive? So for example, adaptive design. And the other is for charting tools or drawing tools, all right? Useful, for example, what you want to show is stock options, okay? So stock options or pie charts, line graph, you want to interact with that from your cell phone. So the resize actually help you a lot. Okay. So as a way to make a quick recap of how do we get here, okay? First, we talk about the platform, the browser, okay? And how we need to understand specifically the roadmap of this particular course, right? So the roadmap of this particular course, which is first we're going to look at the introduction, the core fundamentals, the DOM API, so we can refresh some of this concept, as well as the web APIs for complex UI patterns, and then get a more hands approach with the virtualization. How can we build a virtualization for that? And how we can look at other components necessary when we are designing these front-end systems, such as the application or the data management. For example, the application state management. Also, the communications API, which is what are the particular protocols we can use to actually communicate with the server. This is the front end. This is the HTTPS or WebSockets or server events. Okay, and we can also use RESTful, but this is more like architectures. And then what are the things that we need to improve the performance of our applications, right? Which is asset management. And last but not least, we're gonna see how can we design is, for example, a social media app which I think this is something important, especially if you're going to provide value to other companies out there. Because at the end of the day, they need that you solve their problems for them. So, remember that after all, we're going to focus that. We're going to make a quick recap of all of these concepts. In the introduction, we look at what are the different components or the anatomy that an application is made of. So we got the front end, we got the API, and the back end. So because in this course we're gonna focus only on the front end, we also need to know the components about that. About that component, right? About that. So we got now is from the components. From the front end, the components are how you can communicate with the data, how you going to communicate with the server that actually is based on this client server architecture, how you going to get your data. So that API communications, or in this, then also how you going to, once you receive that data, how you going to manage and store and access to that in a way that is useful and compelling to the user. So the data management. Also, what are the patterns that we need to build as a way to solve some of the common problems, or as a way to provide a better user experience? Because eventually, sometimes we're going to be part of the consumers of their applications. So the developers also can be consumers of that. So for that, so what is this UI interactions pattern? Okay, so for example, like this, and also how can we now manage all of our assets in a way that is that we can provide the best user experience, which is the asset management. So because of that, we need to understand is now these core fundamentals, and that is, so understand now how the browser treat HTML elements, and that is understand the box model, okay, which is something that we have here. The box model, what is the box anatomy, what is the properties of this box. So you have now the type, the size, and the types, and the size can be inherent or restricted. So you provide some sort of rules, or it applies some sort of context, formatting context, which is something that in the types of boxes like inline, anonymous, and block, each one of them not only have its own rules of how this element is going to be displayed, but also is how this element is going to be part of, which is the formatting context. And this particular concept is the way of how now the browser identified that elements inside of this formatting context are not be affected by others rules or by others elements, okay, and how this formatting context, which provide now isolation as well as scalability, because not only you with each one of these formatting contexts, which can be block or inline or flex or grid, each one of them has their own set of rules, which makes them, of course, scalable, because you only have to indicate to that box or that element how you want to these elements behave by providing this formatting context, and that makes it predictable, because you already know the rules that are going to be applied. So then we look at how the browser position elements here, and that is using their normal flow. And when you put elements outside of the normal flow using, for example, via CSS property like position absolute, relative, or CSS transformations, So you are telling the browser to create now this thing called a stacking context, which is something that the browser can use as a way to not only isolate elements here in this stacking context, but also for optimizations. Okay, so we look at what are the specific rules that is applied when you run the position absolutes and the relative, how now the absolute behave, especially that it needs to go through a container to the closest relative container. You must specify that clearly, or it going to the initial block element, which is the HTML, right? So, as well as how the relative is going to behave, it won't affect how other elements are positioned because it create now this stacking context. Okay, and understand this is something important, especially if you want now to prevent some of this thing called reflow. So what is reflow? It's one of the part. We can take a look at this. Okay. So reflow is one of the phase of the entire critical rendering path, or the way of how the browser now transform HTML, CSS, and JavaScript elements into pixels on the screen. So initially it takes the HTML and transform into a DOM, the CSS and transform it into CSS object model. It generate now the render tree as well as parsing the JavaScript code. And in this render tree, that is a data structure, it's a computer data structure as a way to organize our data in a tree data way, in a tree data structure. Further explanation of this go beyond this topic. The whole point of using this particular data structure is that it allows us to access to the informations. It allows to get that information, insert and remove elements fairly quickly, in contrast with other way of organized data. So you have no hash or arrays, linked list, double linked list, or a graph. Okay, so that's one of the reasons why we are looking at this, and this is quite interesting. I get it. And this is quite interesting because I started to understand when computer science becomes very, very powerful and interesting. Yep. And it's starting slowly to understand that, man. Yeah, and slowly to understand why mathematics, especially geometry, okay, becomes increasingly important, especially as a way to organize our data. And the mathematics is just, again, I'm taking a huge tangent here. I'm gonna make it quickly. So the mathematics here is just this. The origin of the word comes from mathema, from the mathematikos, the Greek word that stands for what one gets to know, right? So that's why we have now in the mathematics the body of knowledge of geometry, Euclidean geometry, as a way to now, given this form, shape, topology, how can we now use that in a way that we can now organize our data, as well as get that data quickly. So how we can now insert or remove or access to the data in the quickest way possible. And the more and more data that we have, how can we traverse that for that? Again, in a very quickly way. So I get it why a lot of these computer science actually are moving toward graph in this particularly topology and that kind of thing, because again, it results quite convenient and quite compelling to organize our data in this particular geometry, right? In a graph. So in any case, but the thing here is that the render tree is created, okay? And as the render tree is created, okay? Yeah, as we create the render tree here, then it passes to this phase that is how the browser now, with all this information, how the browser is going to calculate the geometry and the position of all of these elements on the screen. All right, this is the reflow, and this is most likely caused by JavaScript. So anytime you, for example, change the geometry or the position of an element, you are triggering is a reflow. And what happened that it will now call the CPU as a way to run that operations. So the whole point of this is to using now specific CSS as a way for us to prevent, to call reflow, all right, by only calling is the phase of repaint, the paint and composite, where now in the paint is where it's going to know that now is it know all the necessary information that is going to put on the bitmap, okay, this representation of the screen, okay, and the composite is that what are the different things that is going, how it's going to add all of this paint. So because one way to prevent this reflow is by using is, for example, in CSS, is transform, okay, and then you can also is using, for example, tailwinds like, hey, I want to accelerate, I want to make this hardware acceleration of this, right? Which is a great thing. And we also look at the composite layer, which is that, hey, how we're going to see how the browser use the GPU, but the composing is where the different, is where the paint parts of the page are putting together to display on the screen. So all the browsers only use CPU, and our new browsers have each a combination between the CPU and the GPU, which makes them great, especially when we want to use now the GPU. So for example, initially the browser graphic API has now a corresponding elements on the render object tree, okay, that's one of them. So if we change the normal flow out of that, we are effectively creating is a render layer for that. But if we are going to now use a graphic layer, in other words, is like 3D transformations or video and canvas, it now create is that for us. So the whole point of this is to see how now the browser create all of this stacking context. That's one of them, as well as the several layers that is made of, right? So on that, by understanding that, right, the whole point of this is to, once we are able to at least understand how this critical rendering path or the core fundamental of the browser, and when we need to interact with the document through the DOM as a way to create is, whether it is a virtualizations or a DOM management library, so for example like Angular, Vue or React, or you want to create your own components, for example like video or a chart graph, how all of these things now stacking each other, and how you can work with them in a way to allow you to build this, or to also is yeah. Okay. So here is just a refresher of what is the DOM API. So what is the global objects that we can have access to through JavaScript. This is not exclusively to JavaScript. We can also use Python as a way to have access to the DOM, or to parse the DOM. So on this, get this information and now have now have access to that using a particular variable. That's something that to me was quite interesting. And then the object that we can have access through JavaScript, right? Which is of course the window, the document, the head, and the body. And when we look at now the structure of this DOM, the bare bone, the anatomy of this, it all starts with the node, right? Which is this representation of how this tree-like data structure is. So this node has other classes, other objects that extend. For example, the text node extends from node, the element that extends from node, where it allows us to represent its other type of elements. So for example, HTML, SVG, or any other XML elements, as well as the HTML document, all right, where now the elements and the documents under the prototype, they have access to the DOM, okay, as well as the window. And when we want to now query this DOM or doing some operations to the DOM, first, for example, querying, we got 4 methods to do that. So we got the get element by ID, which is blazing fast, pretty much like accessing to a hash table, a property in a hash table. All right. So the read cost and time complexity and memory cost are all 1. This is also becomes an anti-pattern because you must be careful about how ID you put on your how ID you put on the elements per se, okay, and what else? Yeah, how many elements you put in there, because you also need to follow some name convention if you want to avoid any elements that get that, so you don't end up with name collisions, all right, or ID with the same name, with the same value, all right. Then we also have is the get element by class name and tag name, where this is now returning you, instead of an element, it return you is now a HTML live collection. So the way of how you can have access to this is in a linear time, but once you get that element, because now the browser actually have some caching mechanism, you can get that pretty fast. So this is the time complexity and the read cost as well as the memory cost, okay. So the algorithm that it does to quickly look at all of these elements is the DFS, depth first search, okay, pre-order, and a combination with the hash map. All right. So why this is important? We need to be careful here with this HTML collection, which is a legacy one, when we access to those information, when we get access to the element, because see, this is a live collections, and if we change or any other part of the element change that, it will be reflected in all other elements as well. So we might not want to do that, right? And not only that, it can lead us our application in a very unstable, unwanky, and undesired state. So all the components that are using is this state, and then you modify. For example, you remove an element, a p tag, and when another functionality requires to have that p tag, is like, you know, things starting to be quite complicated there. So because of that, query selector now, instead of returning us is a HTML collection, it gives us a element, right? So the read cost or the time complexity here is O1 or ON, depend of the selector here. It uses CSS selector here. And the read cost and the memory cost is actually a constant time, because it's just looking at that data. It's just to traverse that data using is it DFS plus a hash map, right? So this is great with query selector, and query selector all, which return us is a collection or a node list. All right. So the performance overview is that query selectors ID provide the best performance, but you need to be aware of an index, or you have some sort of name convention to avoid collisions. Get element by ID, get element by class name and tag actually provide a low memory overheat, but it now introduces this it now introduces this indeterministic behavior when we read our elements, because since we are now interacting with a live collection, which is the real life, the DOM at live, it can lead us into a wonky state, an undesired state. And the other is the query selectors, which is often slightly better than the get element by ID. However, it contains some catching mechanism. It returns now a copy of that portion of the DOM, okay, not a live collection, which is something good. Similar with the query selector, where now this provide a high memory overheat, and it returns a known live collection. So why this is important? What is the DOM best practice? So, well, that if you're gonna use ID, okay, use that for core components, okay, and they gonna be act as the starting point, or start them with the right starting points, so you can get those elements when you need it. And for the query selector is that the smaller the query, the better off will be, right? Because now it doesn't have to check for all of this condition. So in terms of adding and removing elements, all of these solutions are horrible. The less horrible are the append child, because it's actually attached the element like that. And the other is when it comes to remove elements, use the element.remove. Don't use inner.html, because what happens is that it needs to, so the browser parse that value, and parsing that value is something that it takes time to that. So avoid to do that. So the first example here is like how we can now creating is this document fragment, okay, as a way to now starting to adding or developing user interface for the user, right? So we use now the document fragment as well as the template, with the template tells the browser, hey, don't render these sections when you load the document, and I want you to hold that in memory so you can use that at runtime using JavaScript. And that's exactly what we did here, right? We create a component here when we say, hey, I want you to now create is a copy of the first element here right now here. So the template I want to get is a copy of the first element, in this case here, the article, which where we're going to take is this starting point. And here I'm going to now query selector, going to traverse that element, that the DOM tree, for it is, in this case for the title and the body, and add the proper data to that using the text.content. Because after all, when you do that with query selectors, there are indeed nodes, and nodes, or yeah, this node node list, and nodes is an object that represents the nodes that contain is the text content for that. This is a very simple example, and it requires you to understand all of these different pieces works together and how they join that. Not only that, and then we started to actually see what are the things that we're gonna do in today's video. So, Web API for complex UI patterns. As I mentioned before, the Observer API, okay, unlike the, so I'm not gonna repeat myself. So we look at the intersection and how can we use the intersection observer, which what it does is to, hey, let me take now, let me actually, which is something that we did before, let me actually get those two elements that we want to understand and pass that into a timer that is going to be run at any arbitrary millisecond, 10 milliseconds, to see if those elements are now is overlapping or they intersect that, if their client bound is intersecting that, right? So if they're intersecting, it means that, okay, so there is an intersection, therefore do whatever you need when that happens. The problem is that we are using solely is the timer, the callback queue, only for the intersection. So if you need that for, if you need the timer for other operations, it'll take some quite amount of time to do that, right? For example, is for showing a counter, most likely. So it will have a negative impact. So the spec developers say, hey, let me now create this particular observer, which I'm assuming that they're creating is now a different queue to manage this, all right? Which is the observer API in the web. We go to Perplexity. Is the observer API in the web? Is the observer API in the browser? It creates, or what is the architecture of web API, of the observer web API? The observer web API architecture is designed to efficiently monitoring and response to changes in the state down or a specific event with the web application. This architecture is exemplified by several APIs, including the intersection, mutations, and resizer. Each of these APIs follow the similar structural pattern: observer interface, callback function, and configuration. This is specified this intersection, the mutation, and the resize. The question is that what is the architecture of the intersection observer API, you know? Is the interception observer API use a job queue similar like the promise object. Exactly. The interception observer API does utilize a job queue mechanism, similar to how the promise object operates. How can I look at this? How can I look at this? How can I look at this? Provide me a link based on an exhausted search, on an exhausted or an intense web search. Okay. The author of the website may not even realize that this is happening, since they might know very little about the inner workings of the two libraries they're using. Let's go register and callback function that is executed whenever the particular elements enter or exit at an intersection with another element or the viewport, or when the intersection between two elements change by a specified amount. This way, sites no longer need to do anything on the main thread to watch for this kind of elements intersection. Exactly, and the browser is free to optimize the management of intersection as it sees fits. But how the browser manage that? Yeah, right? Can do trigger logic based on an exact number of pixels that overlap, or specifically on which ones they are. It only solves the common use case that of if they are intersect by somewhere around n%, I need to do something. Typically, you will want to watch for intersection change with regard to the element's target closest, scrollable ancestor, or if the target. How intersection is calculated. All areas considered by the intersection observer API are rectangles. Elements which are irregular shape are considered as occupying the smallest rectangle which enclose all the elements part. Similar is the visual. The root intersection rectangle. The root intersection rectangle is a rectangle used to check against the target or the targets. So this is the root intersection rectangle. Okay. This rectangle is determined like this. If the intersection root is implicit root, that is the top level document, the root intersection rectangle is the viewport. Exactly. The root intersection rectangle. If the intersection root has an overflow clip, the root intersection rectangle is the root element's contact area. Otherwise, the root intersection rectangle is the intersection root bounding client rectangle, as returning by calling the getBound client. Okay, if the intersection root has an overflow clip, the root intersection rectangle is the root element's content area. overflow clip. The root intersection rectangle is in the intersection root bounding client rectangle as returning by calling get bounded client rect on it. The root intersection rectangles can be adjusted further by setting the root margin. Root margin in the example below, we have a scrollable box and an element that initially out of view. You can adjust the root right margin and see that if the margin is negative, if the margin is positive, then even when the red elements start to become visible, it is still not considered intersecting with the root because the root bounding box is shrunk. Set the right margin of the root. You can also use this slide to scroll to the container. Exactly, with the viewport. Threshold. So this is also to understand ourselves, clipping and the intersection rectangle. The browser computes the final intersection rectangle as follows. Starting the target elements, if one contains an... Okay. So, because we know more extensive example, add timing element visibility with intersection API. As a way to define a counter for this. Eat green beans. Interesting. Again, this is the intersection observer, right? And they have a particular way to work with. So you have to so all of these follow the same particular pattern. All of this intersection, all of this observers API follow the same particular pattern, right? Whether it is you have now, let me make a quick pause here. So the thing here is that this observer, this interception observers like this, these observers follow the same particular pattern, which is at least the intersection in the mutation. You first define as a callback, and in the context of the intersection, you receive now the entries as well as the observer as a callback function, and then you're going to decide which, based on these entries, which is going to record all of these events that happening, okay? If the elements that you're putting into the root configuration, so for example here is the element that you put in the root configuration. So first let's going to define as a callback, right? So first you define the callback, and then the observer, and then you now run the observer, okay? So this callback, or let's going to start with the intersection observer here. When you create this new class, when you pass the callback as a first parameter and then the options, initially if you don't put any root, you just say, hey, use the viewport for me, okay? That'll be the as they call here, the that'll be the root intersection rectangle, right? That'll be the root intersection rectangle, the viewport, or you can define another elements here. So when those elements actually overlapping, okay, and most of the time we do that is with the viewport, because that's actually what most of these common use case, like for analytics, virtualizations, adding dynamic elements to that actually works, right? It's not for virtualization or lazy loading components as the user goes to fit in the analytics, or loading dynamic UI elements. So the intersections allow us to cover these most common use cases. All right. So it means that this option that we're passing here is the intersection, the root intersection rectangle. So it can be the viewport or any other elements, right? And then you're gonna pass is the threshold, which is the ratio in which this callback will get triggered when the intersection of these elements happen, when this limit or this threshold, with this ratio threshold happen. And the callback that you're gonna do here is to say, hey, this is the entry, this is the observer, I want to check in each one of those entries here, a threshold, that kind of thing. Here they actually mention is this, the intersection change callback here. The callback passed to the intersection observer construction receive a list of intersection observer entries, objects, and the observer. So the list of entry received by the callback include one entry for each threshold crossing the event. It's like, hey, I'm receiving is this entry when that happened. So when that happened, hey, you're actually getting that, which is a great thing. So is now the browser that is handling is this in a particular queue. When it detects that, it will now run the callback. It will now notify you with this entry. The entry are dispatched using a queue. Exactly, the entry are dispatching using a queue. So they should be ordered by the time they were generated, but you should preferably use entry.time to correctly order them. That's quite interesting. Example of time and visibility with intersection observer. Timing element visibility with intersection observer. Okay. Mm-hmm. Mm-hmm. This is when we need to access to this example here. Nope. You need to be on the. No, I'll need to access to the. Did I put it here? No, I did not. Okay, no problem. So code send. That's right. Yeah, this is code send here. Accident encounter, Dog API performance, HTML collections, Dog API performance, an HTML collection example. No, I think it's this. The intersection observer. There you got it. They're running out this process in their servers, and they now send me this. Jesus. And now they send me this, where now my browser is actually running this. It's on my side that is running this, based on all of this information here that is provided. And of course they have some metrics to actually know more about that. Redux, React, emotion style component. Using smart code, web frameworks. Apple sign in, Monaco editor, rich text editors, Core.js, Code Sandbox.io, Code Sandbox, okay. Web frameworks, Next and Express, Laravel, Ruby on Rails, Nox, Needle. Code Igniter, oh my god. As long as it works, like. Tailwind. OpenJS and eBay. Oh, eBay open source. I get it. Why a lot of those companies actually is using is open source, that kind of thing. It's a way to let others use that particular tools, but for Facebook has helped them a lot. But a lot. But a lot. A lot. A lot. But a lot. Okay, cool. So, at them. Um, oh, because you want to exactly get some data here. Okay. I'm not sure if this actually going to trigger that bottom observer. I would like to do something like this, because now it's triggering is this, okay? And right now we are looking is at the intersection observer here that is returning is, so now the intersection observer here is going to call this callback, okay, with this entry, which means that, hey, when this threshold happened, this is the data here, and this data here of the intersection observer entry describe the intersection between the target element and its root container at a specific moment of that transition. It's like, hey, okay, this is describing is the intersection of the target and the root container at that specific moment. That's something interesting, because in my particular case I want to test something like this. When I say, hey, because this entry describes the intersection of the root container and the target element, I want now to get is the time for this, bro. Save it, and not sure that it's going to do that here. Or can we do something like this? On the title, we can is now do something like this. So we can create is a new state that I want to mutate state following is a functional programming approach as a way to try to prevent, as a way to try to identify when an error, as a way to try to prevent, as a way to try to prevent errors when they happen. As a way to try to prevent where bugs will happen, and avoid them by using patterns that never allow them to happen. So here what I'm doing is just the how do you put it? Oh Jesus! This is for the React, but the Redux. Okay. Okay. So one of the things that functional programming does is to try to predict where the where the errors or where the bugs are gonna be. In this case, what I'm trying to do is to predict where the errors we're gonna be. I know this is a very small application. There is no need to actually worry about that. But think in this small case, so we can scale that up, is something that is helpful. Pretty much like you hit the gym, or you're starting to do small exercises with a little bit of weight, and then you progressively go on and move on, so on and so forth. That's what we're doing here. So the thing here is that because I don't want to mutate the state, and I want to follow is the functional programming approach for this small tiny case, only to say, hey, one of the things that functional programmer does is to try to predict where bugs are gonna be, avoided by using patterns to that never happen, by using pattern where they can happen. So this particular pattern, the way they can happen, this box is, especially if you want to pass down to, if you're gonna pass data by reference, in value reference, here you say, okay, now I'm going to create now a new title, which is say title with time. Okay, when I say because I want to use this string interpolation here, like so. I want to say this is now the time entry. What the French told you did? Okay, is time entry, and then you put here now the value of that time entry, which is entry. Okay, entry dot time followed by the title, right? Period. Title with time. That's what you're gonna pass to down to this. You save this, and if you want is to you say you refresh this, okay, and then you got is this. The question is that I'm receiving this. I'm receiving is this time, like what? A dumb high res timestamp indicating the time at which the intersection was recorded relative to the intersection time origin. Time origin of the performance. The time origin read-only property of the performance instance return high resolution timestamp that is used as the baseline to perform for performance related timestamp. Exactly, value. A high resolution timestamp which is considered to be the beginning of the current document lifetime. It is calculated like this. What? Document high res timestamp. Timing attacks and fingerprints are cores based on the site isolation status. Resolution is isolated context 5 microseconds. Resolution is not isolated context 100 microseconds. This header ensures a top-level document does not share a browsing context group with cross-origin documents. COP process isolate your documents and potential attackers can access to your global object. If they were open, it would pop up, preventing a set of crossing origin attacks .exe. Okay. That is not clear to me. But in any case. So in any case, this is data. This is the time entry. You know, this is the time entry. So when was the last time this was this occurred? So again, this is quite interesting. I did this only to know what will happen there, okay, and how to render that, okay. But yeah, the thing here is that with this interception observer, which is these objects that we're going to first initially pass the callback, and this callback contains all of this entry that is described as when an intersection between the root element and the target happens. So it's just describing what happened there, and they provide you some options, which is it's intersecting, and then is when you're going to see, okay, now let me get all of this data, and as I get all of this data in a collection, I'm going to now populate what I'm going to create here, all of this fragment here. So I'm going to create is this fragment as it is. So this document fragment that we are looking here is as a way for us to create now is element. It's a minimal, yeah, interface represents a minimal document object that has no parents. So this minimal representation of these documents, where we can now append elements for this, which as you can see here is now inherited from the node, okay. We can append elements, okay, and those elements that we're going to append here are elements that we return, okay, are elements that we return. You can see here, they are elements that we return from the create car elements, which is now this small elements that we are getting here from the template. We're already populating that. We are populating that and append that to the fragment here. Next data, we're gonna do the same. Populate that, create that, and then append that to that, to the DOM. The same process. Get that data, create the components or the document, and then append that, and so on and so on and so forth. As you can see, that's actually what it's doing in the browser. All of this set of instructions, okay, and this is only to append all of these elements on the fragment, okay. And then now that I have all of these elements generated on the fly in JavaScript, I want to append all of these elements into the list like this, you know, into the list, which is an element that I must be defined here in the main body. Exactly, into the list. It's like, hey, this will be the entry point for all of these elements that we put in there. So again, all of this is a way of how you can define this user interface on the fly, all right, by using this existing API. That's quite interesting, my friend. That's very, very interesting how you can provide now this, for example, virtualization. Pretty straightforward, right? Pretty straightforward. The next, okay, let's go to create now a branch from the, of course, intersection. I would like to do that. That's quite very, very interesting, and also to understand is the intrinsic nature of that. How can I create now a fork of that? And then I say is mutation API. Please create is now a fork from this. That's what I want to do. What I want to create. That's right. That's right. That's right. Okay. Awesome. Awesome. All right. And well, let's now take a look at the mutation. What in the F is this? The mutation. The mutation star. Right. Good. This one. All right. Be my guest, my friend. Be my guest.
Let's go to the mutation observer now. So the mutation observer is different because it allows us to track the changes within the DOM subtree. So it's very useful for rich text editors. For instance, you're trying to select some data and apply the bold text. So the mutation observer will allow us to detect that. The huge benefit of the mutation observer, it's implemented on a native level. So previously in vanilla, how this mutation observer will be polyfilled is you're basically creating proxy objects that will track every mutations of any possible subtree. And this is implemented on a JavaScript level. So you would need to create, like, if you have a large subtree, that will result to some memory issues. And since on a native level, it's very fast. And the creation of the mutation observer is pretty simple. We just need to provide single callback. There's no options to the constructor, and the callback accepts the mutation. And the observe function accepts two parameters. One is the target node that we're trying to observe. Here, in this example, it's div, and the observer options. And the observer options is a bit more complicated because we can track many things. So we can configure the observer to track only the child list. So this means that we go if we provide the child list true, then we're going to track the section and H1 because they are a direct child of div element. If we provide the attributes to true, this means that the intersection observer the mutation observer will track any changes in the attributes. And if we provide the character data, then if we have any text content and we enter this content using the keyboard, then the mutation observer can detect these changes, like on change on the inputs, and provide us with the mutation observer entry. And there is also one cool thing, is the subtree. So we can basically say that we want to track all the elements in the whole subtree, and we just need to provide the true flag here. We can also filter the attributes that we're currently looking for, and this will reduce the number of times the callback is called. So the best practice is to make sure that you configure the observer in the right way, so you don't try not to overuse the properties. Don't set them to true, because this will involve invoking the callback too many times. So just make sure.
So just to clarify, the child list would just apply to direct descendants in the subtree.
Because this will involve invoking the callback too many times. So just make sure.
So just to clarify, the child list would just apply to direct descendants and the subtree would be any.
Yeah.
Okay.
So the child list will be supplied to
the callback too many times. So just make sure.
So just to clarify, the child list would just apply to direct descendants and the subtree would be any.
Yeah.
Okay.
And there is a conflict. If you apply child list true and the subtree true, then the subtree will not work because this child list has the preference higher priority. Okay, so the TLDR, make sure that you configure these options right to reduce possible invocation of the observer callback. And the mutation record that the mutation observer provides us is basically has a few properties. So the type tells us which type of mutation happened. It can be the attribute changed, or some data was entered or removed, or there might be that we added a new DOM element in the direct child list. So it also has the information about the target node, which was triggered the mutation observer, and we also have the added nodes array that will give us any newly added nodes that were when we inserted some data in the DOM tree, or removed nodes. And we can also access the old character data value to see what was the value before the mutation happened. And again, the callback is pretty simple. We just need to loop through the mutation, filter it by our type, and write our logic.
So it's quite similar to the intersection observer, where now you receive this as callback and the entries. You receive these callbacks as the entries, but this is the mutation, and the mutation is describing. This is quite interesting, man. Mutations, the mutation observer. The mutation must describe is what. Yeah, because the mutation observer has the ability to watch for changes being made to the DOM tree, and it is designed to be a replacement for that. Good. And it's the instance is connect and observe. Okay, you have now the mutation record, which is a read-only interface that represents an individual DOM mutations observed by the mutation observer. Is the object inside the array passed to the callback of the mutation. So is the object that is passed through the array of the is the object that is passed to the callback of a mutation observer. So you're going to receive this object whenever an individual mutations happens to an element, to a target element. Okay. Okay, so what is the mutation record? Here is this object that is passed to the callback that represent is individual mutations to the target elements, to the target DOM. Hey, added no, attribute names, attribute namespace, next sibling, all value, which is a mutation record of this. Attributes, character data in child list, previous sibling, remove node, target, type. Interesting. Very, 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 very interesting. Attribute namespace, attribute names, next sibling. So with the name of the attribute that changes as a string, the attribute namespace, the next sibling, the old value, the previous sibling, the remove dons. Okay, the target, which contains the attributes, character data in child list, and the mutation type. Okay, all right. Okay. So it's this one. All right. Okay. Cool. Cool. All right. So unlike the intersection observer, this now has this particular way. You have the callback, but in this case, receive mutations. You're now going to instantiate is the mutation observer, and then the observer, and then you're gonna then you're going to now run the function that observes the target element. Okay. All right. Okay. Not sure where is this. Yeah, not sure where is this. And okay, it will work here. Yeah, it's supposed to work here. It's supposed to work here. Exactly, it's supposed to work here. Exactly, it's supposed to work here, but it's going to throw some of this error. Okay, get headings. Wow, this is a very low level stuff, bro. It's a very low level stuff, bro. It is very manual. It's very manual. Very, very, very highly, deeply manual, bro.
Interest rates. Two pretty short words, but in the time that it takes my brain to process. Wait.
All right, here we go. Right. Of course, there is some missing dependency here because this is now laid out in this particular way, which is you have the index, right? You have now the utils, where now the utils live outside of this. Please be my guest. Move it. Hello. I put this. Where is the utils? That's right. This utils in fact is going to contain a little bit more of this. Yeah, this utils will contain is only this, right? That's right. And okay, and we need the mock data for that from the utils, which is the database here, which is this one, and of course that is the utils.js. Alright, makes a lot of sense. We save this. Alright, then we save this. The init mock in fact is on under the utils. Exactly. So we save this. That's right. You're supposed to reference in that, but in this case is the DB. Is it DB? Okay. Interesting. We called him as DB. DB. That's right. Oh, holy fuck. .gs. DB. And that'll be all. Right. So we save this. When we try to save this, please, be my guess. All right. So when you want to now go to the utils, of course, there's some styles missing here. Where do you? Okay. No. You can define here in the style here for, or you can say it's only something like this. That's right. So now the browsers know all the information needed to actually render them properly. Okay. And they'll actually do that fast, bro. Pretty fast, bro. Alright. So here it doesn't complain about this. It's not complaining about that, hey, this is a type model, because when I run that locally, the browser say, hey, no, I won't load any of this file here. No, you must run a dev server and then do that. And to me it was like, no, ain't gonna happen. To me it's like, ain't gonna happen. So here this is the mutation, right? And then mutation, you say, hey, loop through the mutations, first argument the callback, use the mutation dot types with character data as a way to, hey, I'm going to detect is when an individual change to this target element happen, and I want to check if their value, okay, which is character data, when the content match with the supported tag in the supported elements, use the get heading function to convert text to HTML heading elements and replace the node with the newly created and keep focus on the element. So the thing here is that, hey, since this is the mutation and this mutation is a for, okay, In this case, let's gonna call this as mutation. It's going to iterate through this mutation. Luckily for us, we can do that using is the for of mutations, since it implementing now the iterator protocol. I'm assuming that you're implementing that protocol. Mutations record, this is the object that we're receiving, but it say takes records. Okay, removes all pending notification of the mutation observer, but here we're receiving is this mutation observer. Okay, this is the mutation observer. Okay, stop, observes, and take records. Okay, and here, because this, okay, from the exercise here, mutation less. Interesting. We can call this just mutation, right? And here we are receiving is an array of that, and that array actually implement is the iterator protocol, which is the way of the convenient, the iterate this particular pattern that allow us, regardless the underlying data structure, we just only care is that we traverse that data structure. I love that. I really love that. It's quite convenient. So okay, let's go to actually check this. Is the mutation the type? So if the mutation the type is equal to the character data, that's something lovely that actually the type, the LAN server, the TypeScript LAN server actually provide to me, which is this TypeScript server that is running behind the scenes anytime you open a file. And here, as you can see, is now running is HTML, which is also convenient. Okay. And if mutation.type is equal to character data, you say a child node has been added or removed. This is child list, this is attributes, but what if exactly for character data is a character data node, the node that mutation affected depending of the mutation record type, for attributes, for character data, and for child list. So if there is someone actually changed that, which is now put in here on the section, is to be this editable, okay, which means is that this particular section the user can now edit that. I think it's that editable in HTML property and content editable. My bad. That's lovely. So if you remove this, is read only. Oh, it's not evaluating. Okay, no problem. But this is a way how you can let the user, hey, you can edit this content. It's an enumerable attribute indicating if the element should be editable by the user. Most of the time, we don't want that. Never trust the user input. But in any case, the value attribute must take one of the following values: true, false, plain text only, which indicates that the element raw text is editable, but rich text formatting is disabled. If the attribute is given without a value, it is value treated as an empty string. So for example, like this. You can set the color using draw the text insert caret, which uses caret color property. Elements that are made editable and therefore interactive by using the counting editable attribute can be focused. Okay, they participate in the sequence keyword navigation. However, elements with the counting editable attribute nested within other counting editable elements are not added to the tabbing sequence by default. Okay, so there is some nuance here. So if I save this, and now this is because the browser didn't re-render that. So now I'm making is this particularly what in the F? What? Close that shit, nigga. Restart that. Update available to the latest version. So I cannot do this. What? What? Util.js. That's right. The style, but now it's not even loading anything here. Oh crap. Okay, I get it. There's some missing. Okay, makes sense. Okay, there's some missing here. Okay, if I reload this, now it's loading all of this. Okay, good. So I just want to make this content editable. Content editable. If you don't pass anything to that, it's actually set to empty string, which means that you can now edit this content. Let's go to reload this, and there you go, right? So you now provide the ability to the users to actually content or edit this, which is great. So when this is so when we mutate this element here, okay, so when we mutate or when we detect this mutation here, the mutation dot target, which is this element that we care about, okay, when the content match with any supported tag in the supported element, okay, in this case is with the target. I'm assuming that is that with the target character data, or in this case with the type. Note the node, the mutation affected depending on the mutation type. Okay, which the mutation target, it can be this. If this is character node, okay, we're gonna get is a node. Okay, we're gonna get is a node here. What we want to represent, what we want to know is, what is that? Character data. In the character data node. So when the set to null value, the null is an abstract interface that belongs to the text and the comment. Exactly, in the data here. So if this data, so if the mutation target dot data because it's this is the mutation type, if the record type is character data, this is a character data node. Okay, which means is this. So as character data node, which means is if the data we can say is now this is the target, okay, and is the supported elements, okay. So if the target dot data, okay, or we can say is the supported element has this data, okay, which is either is a H1 or H2 or H3. If it is, okay, so now let's actually is to create that, okay. Let's actually append that element. In this case, create element, get headings. Get headings here is that you're gonna pass is that node. Exactly. This is also following is best practice here. Is that, hey, this is a node. Is this node contain the text node? Start with this. What you're gonna do is to create the element and return that element. Which is here is say, well, now it's going to call is the get headings. Get headings. And we're gonna pass the target, which is, after all, this target is part of a node, and this node must have is all of this property as we mentioned here. So get heading now actually going to return us the element that we want to. It's going to return is the element the proper element that we that exactly this element, okay, is returning us the element here. Exactly, it's creating the elements here that we're going now to pass to the create card element. to the create card element of the title and the body here. Okay, I get stuck here because at the end of the day, we want is to append that element here. We want is to append that element there. But after all, we want is to get that element here. Okay. Since we are receiving is the mutation, which means since we are receiving is we need to indicate that which elements are we going to listen to. Where in this case, so what is the elements that we want to all get all of this? Because here we're detecting is this, and then we want is to append that element, right? That's quite interesting. This specific part is like, what the fuck is this?
So I'm at all the supported elements. So let's do that. Just any element in the collection.
Which is exactly what I did. Yeah, okay, makes sense.
And if it does,
Okay, target.text content. Oh, target.text text content. Okay, why target.text content? Not the data from the node text content. Okay, from this interface that is actually contained is the text node that we are already writing here.
Then we are going to replace. We are going to create a new heading and use the getHeading method and pass our target node.
Exactly.
Okay, so now we have our heading method. We can now
So the thing is that now that I get here is like how we going to replace that element to there. So one way is to actually get an ID elements and then replace that. Or
replace the target element using the method called replace with. So it basically replaces the target with a new heading element.
So what you're doing is you're replacing is a target here. Okay, we're replacing is a target here with this. Okay. Hey, replace the target with this new heading.
And now we also want to focus on the newly created element. So now the mutation observer is implemented.
So but what we're doing here is that this target elements that I indicating here, to actually modify that, I want to replace with the heading.
But we still need to track the elements. So here in the append child, what we're going to use is we're going to use the mutation observer, observe, and then our card element and the configuration.
Exactly, and this element here that we're gonna use for that, god damn it, bro. Okay, so these elements, I want you to mutate, to transform that into something. Oh, hell, fucking god damn it. So, and this one, okay, so what we wanna do here is this, is to say, hey, this is the element, okay, that's right. So I want now to this element, what I want now to the target element here, replace exactly, it's going to complain because he say, hey, what in the F is that? This mutation is mutation dot target dot text content. Exactly. So what we did here is to say, well, give me that target, give me that target, and I'm going to replace with that. Exactly. So give me that target, okay, from the mutation dot target, and then I'm going to pass that target element that I'm listening to for change, which is a node, a DOM node, okay, and I'm going to pass down that target, which is an element or a node, all right, and once I pass once I pass that node, I want now to the target replace that I want to the target replace that with heading. Replace child. I think it is child, not replace that, because at the end of the day, this is a node, and we want is to replace that. Replace child, exactly. Not replace with. Oh, but it's replaced with character data. Interface replace this node in the children list of the parent with the set node object here. String are inserted as text node. So from the character data, you say, hey, I want you to replace that, replace with, okay, this element. So this replace with, what it's gonna say is to look at that. This is part of the character interface. Replace this node in the children list of its parent with a set of node object or a string. So I'm going to replace this node and in the children list. Okay, replace this node in the children list. Replace this node in the children list with this, and then focus on that. Keep focus on the element, which is element dot focus. So after all, this element here is an element, and because this is a type of element here, the property that it has is focus. focus. Okay, I think it is focus. Okay, focus. Because it's an HTML element. Alright, so it's focus, and this HTML element is part of the, okay, it inherits from that. So, okay, so focus is part of the HTML interface. When you say this is part of the HTML interface, so I want you to focus on the element after you do that, right? Yeah, so after you do that, right? And then, because here's when we are going to register is the observer to say, hey, I define this global, this mutation observer, and this mutation observer that now is going to observe this particular element, and that is the car, because what I'm doing is attaching this mutation observer to all of these elements to this car from that, followed by these options. And these options here is where you have now the let's go for the mutation the mutation observer here, and the options that you can pass to this, the mutation observer, and the options that you can pass to that. All right. We don't treat the mutation observer mutation records, but the configuration that you can pass to the observer as the option. Okay, because here you're telling us that when that happens, when you detect a mutations in these elements, so when the context, so when the text element change here, for example, when change, I want you now to replace with this new element. And this target, which is something that I already indicated, which is I'm going to now observe each one of those elements, okay, that I'm creating dynamically following these particular options. And this particular option, as you can see here, this particular options, as you can see here, okay, yeah, this particular option, as you can see here, attributes, character data, and child list. Okay, what I want only to check here as a way to reduce the number of checks that you have to do, which is by looking at this to say, hey, and here, okay, and say, hey, you know what, the type of mutation that I want you to check is only the character data, right? Is the character data. So what to track? What to track? Character data. Only that, bro. What to track? Character data. What's next? Target. Okay. Which objects to track? I already indicating you to do that, so I know there's no need to describe that. Added node list. No. Remove all nodes. No, it's this one. Character data is true, and this is observer options. My bad. This is the observer options. Exactly. The observer option is like character data by default is true. Let me actually see if this is as expected. The options here is that subtree is set to true, but in this case I don't want to set that to true. In fact, I want to set that to false. Okay. Set to true to extend that. The default value is false. The default value is false. The attribute the default value is false. The attribute filter as well. The attribute all value, the default is false. The default is false. Okay. The default value is true if the character data all values specified, otherwise the default value is false. Okay. And that's it. So this is the only property that I want you to keep track of. Okay, which is the character data. True. Just like that. No more, no less. And that's all. Holy shit. And that's all, bro. And that's all. So for example, when you put now here is an H1, but I think this must be something like this. No, it's not detecting that. H1. Nope. Replace with element is not working because I think that this must be replace child with this element that was created. So when you reload this, is this what you say character data only that
is implemented, but we still need to property to verify that we do the deep check and
okay, and we need to do the deep check here for this particular element. Okay, for this particular element we need to do the deep check for this. It makes sense because this is a nested object, it's not on that element there. So if you put now this and if you reload this,
check the data to true, the rest will be false. And if we open the
but it says, I say a replace with, okay, if I refresh this and I say H1, now it's working, but it's replay with. Heading. And if you say H2, H2. Even if you're doing deep check, because if you don't put this, it's not going to deep check that. It's not gonna deep check that. Oh crap. Exactly, it's not gonna deep check that. It's just only checking for this target, and the target here that are putting is the car, but it's not in the car, you know. Okay, so what happened with this is observe is if any of these elements on the subtree change, now you're going to run this callback here, subtree to true. God damn it, bro. There is a lot of mechanism going on down there. So you got H2, H2, and H3, and that kind of thing. Jesus, French toast guy, bro.
And last thing that we forgot is we need to add the content editable property to the section. Now the content should be editable. So we created mutation observer, access the target and a type of mutation, check that the type is chart data.
Const a target and type. This is also a thing that you can do here, because you know that this actually is the okay, that's quite interesting in here. So instead of doing that, you can say, since you already know that this is an iterable, that you're gonna get the target, okay, as well as the type. So you can now check if the type is the character data, and you're gonna pass that target down there. Holy moly, bro. So if the target exists and contain text content, all right. H1, when there is a mutation in all of these elements that match this condition, okay, that is say, hey, it changed its text content and has now this. All right.
Check that the text content contains the specific set of characters we're looking for. Generated the heading element and replace it with a new element. Yep.
Is there a possibility of infinite recursion here, where you're changing the target element and then it causes the mutation to fire again?
No, because in this case we are creating is dynamically, and there is no way to triggering is that.
Yes. So you need to be.
There is no way to. And this in this case, this example is not. But yes, you need to actually be
careful how you change that.
With how you change.
So here we do not check. We check only the chart data mutation. It's basically when you type. But because we insert the element and we update the element before we insert the data,
in this case, because we are creating and then insert the data onto that recursion
is not happening.
On a personal note, we use Google's CAPTCHA, and the only way that we could detect that certain things were loaded was with the mutation observer, because it was like they'd keep the third-party APIs in a sandbox or whatever, and it's just like the only way to know if this DOM was changed was with that API. It's interesting.
You could potentially do the interval where you traverse the specific domain looking for a certain element, but it would be much slower than the mutation observer.
Yeah, and this way we were able to see, is this element, changed, and if so, okay, then run our code. It was much more efficient.
Yeah.
So it's a good API.
Any more questions before we jump to next section?
Someone also said they use Mutation Observer in a Chrome extension to make sure that the extension stays in sync with the rest of the web page that it was modifying.
I think the Grammarly, the popular exception for checking the the grammar also use the mutation observer. They basically check what you enter on the data. But such extension may reduce your website performance.
Yeah, because it's constantly checking that.
Data. Grammar also use the
Checking the grammar. Oh.
mutation observer. They basically check what you enter on the data. But such extension may reduce your website performance.
Yeah,
because
for
it's
sure.
Around the callbacks.
All right. Holy moly. All of that was to recap about the mutation observer and how you can actually quite do that. So that'll be all for this video. Take care. Bye bye.